Hello, and welcome to Pharmacist Answers. I'm Cynthia, and I will be your host. You're listening to my Periscope broadcast turned podcast. Hope you enjoy. In the past, the previous topics that I've talked about when it comes to your liver, I've talked about the things that your liver takes away and the things that your liver does to break things down and to take them apart. But there's actually a process that your liver does to produce things for you. Your liver produces three very important components. Two of those components are involved in the way that your blood clots. And then the third one is also involved in your blood, but it has to do more with your blood staying watery. So the first one involved in blood clotting, it's called prothrombin. And a lot of times in medicine, when you have the word pro stuck on the beginning of something, it means your starter kit. Just like a prologue is at the beginning of the book before the book actually starts. It kind of has all of the pieces tightly contained together to get you started before you start in chapter 1. A pro something in medicine, so prothrombin, that pro means that it's the starter piece, but it's not the usable piece. So there are things in medicine, we call them prodrugs. So it's the starter part of the drug, but it usually means that your body has to do something to activate it to actually make it the usable drug. So there's just some medical terminology. But prothrombin is a precursor to a clotting factor and obviously blood clots, if you get hurt, are good, like Prozac. Not quite. Prozac is a trade name, and they have all kinds of branding people that work on coming up with drug names to make them catchy or memorable or something. So where, for example, for drug names, Albumin is a sleep medicine, and it means AMBN. So BN being good in Spanish, so having a good morning. If you can sleep, then you have a good morning. So see, they come up with all kinds of tricks that I don't even know all of them. But they have a whole marketing branding team that works on brand name medicines to come up with things like that. So it's not exactly the same. But actual chemical names, in medical terminology, that pro does mean the starter, that starter piece, but not necessarily the active piece. So prothrombin gets activated after it's made by the liver. It makes prothrombin. Prothrombin hangs around. It doesn't do a whole lot if it's just hanging around, but then if you get hurt and your body says, I'm hurt, I need to clot so I don't bleed all my blood out, then your body starts this cascade and prothrombin gets activated into thrombin that then continues down the process to lead to an injury or an open wound being clotted, so you don't lose all your blood. The second component of your blood, of the blood clot part that your liver makes, is called fibrinogen. So another medical terminology, Gen sounds like Genesis being the beginning or the start. So fibrinogen is again a starter piece, but not necessarily the active piece. So fibrinogen gets activated into fibrin, and that becomes a part of your blood clot. So this is a very elementary process, an explanation of a blood clotting. You get hurt, your body says, ouch, I'm bleeding, I need to stop bleeding. Your cells activate all of these factors, and the factor 10 is a clotting factor. So clotting factor 10 turns prothrombin into thrombin. Then thrombin acts on fibrinogen and turns it into fibrin. And then fibrin sounds kind of like it is, meaning fibers. Fibrin, rather than being, it's a protein. Some proteins are called globular proteins, and that means they're just kind of all balled up in like a glob. Fibrous proteins are fibers that are long and kind of nice and symmetrical and nice and stringy, like fibers. So fibrin is a fibrous protein, and the fibrin lays down in the place where you got hurt, and then the platelets in your blood collect on the fibrin and fill in all the gaps so the blood doesn't keep leaking out, and that's how you make a blood clot. So that's bonus. But those two things made by your liver, those are very important, because if you didn't have those, then you wouldn't get that matrix for the platelets to build on to actually form a blood clot. And there are several different bleeding disorders that, if certain parts of that cascade, the complicated cascade, don't work right, then you don't get the right end result. Also, if you have too much of any part of that cascade, then you end up clotting too much. And that can lead to those fibers getting gunked up and collecting things and causing blood clots in your blood vessels where they don't need to be. You need the blood in your vessels to be nice and liquidy. You need blood coming out of your body to harden and stop, because it needs to stay inside. So then the third protein that your liver makes for your body is albumin. And albumin isn't just a human protein. Albumin is found in the egg whites, in the whites of eggs. It's kind of gooey and real watery, and that's what it does in your body. It helps maintain the wateriness of your blood, because again, you don't want your blood to get hard and gunky and goopy, because then it like blocks off places that it needs to go, and that leads to all kinds of problems. So the albumin does two things specifically that kind of are together. It maintains the osmotic pressure of your blood and the cells in your blood. So osmotic pressure just means that there's enough, the difference between the pressure inside and outside is different enough that it can push it through the membrane without there actually being an open door. So if you think about a mesh strainer that you use in your kitchen, sometimes if you have little bitty droplets of liquid in it, it just sits on top of the mesh and it doesn't actually flow through. But when you get enough liquid to give enough pressure to push it through that mesh, then that pressure allows that water to flow through the holes. So that's how your cells work. If the pressure on both sides of the cell membrane is the same, then there's no transfer of nutrients and tools and chemicals and things that your body uses. But if one side has a little bit higher pressure than the other, then it's able to push the fluid and the things that are dissolved in that fluid from the outside to the inside. So that's what albumin does. Albumin maintains that pressure inside your blood, so as it flows past these cells that need stuff that's in it, the water gets pushed from your blood into those cells and carries those tools into the cells so it can use it. That kind of makes sense? It's kind of complicated. A lot of chemistry involved in that. But with that process, it also helps your body maintain and continue to be isotonic. And isotonic has to do with the saltiness. You don't want the fluid in your blood to be more salty than the fluid inside your tissues and your organs, because salt attracts water. So if there's more salt in your blood, then it's going to pull the water out of your cells, and the cells aren't going to have enough water. But you don't want the water inside your cells to be more salty either, because then it's going to suck all the water out of your blood too. So the albumin helps maintain the saltiness and keep it even enough so that hopefully the only thing that's helping the nutrients and tools that your body makes and that your blood carries, the only thing that's causing them to transfer is the osmotic pressure. So those are some things that your liver makes. Well, those are the three important things that your liver actually makes. It takes the building blocks and puts these proteins together and sends them out to your body. Where the other processes in your liver usually have to do with them getting something that you ate or that you consumed or that another part of the body made, and then your liver just manipulating it into being usable, or after it's been used, making it inactive so it doesn't keep circulating so you can get rid of it. So we'll have there's one more process that your liver does that's very important. We'll talk about that tomorrow. I'm gonna go. Y'all have a good day. Bye.
Thanks for listening. Be sure to subscribe to the show on iTunes so you don't miss an episode. You can find the show notes at pharmacistanswershere.wordpress.com. If you want to join the conversation live, follow me on Periscope at Cyn Hendrix, CYNHENDRIX. You can also share your questions and comments with me on Twitter at Cyn Hendrix or email the podcast at pharmacistanswershere@gmail.com.